What's going on, guys? Let's try these problems right here. The first question is asking a dipole with a positive charge of 2 microcoulomb and a negative charge of negative 2 microcoulomb is centered at the origin and oriented along the x-axis with a positive charge located to the right of the origin. The charge separation is 0.8 millimeter. Find the electric field due to this dipole at the point x is equal to 4.4, y is equal to 0.0. And here the question is asking find the electric field due to dipole. So when we have electric field due to dipole, we can use this equation. E is equal to kq times 1 over r minus a square minus 1 over r plus a square. Right? So here we know that k value 9 times 10 to the power of 9, q is the charge, and r is the points distance, that is 4.4. okay, and a is the midpoint of the charge separation. So if it's 0.8 millimeter, half of this value, right, that's going to be 0.4 millimeter. Now let's go ahead and plug the values, and that's going to give us the final answer. And we know that k is equal to 9 times 10 to the power of 9, and here we have charge that is 2 microcoulomb, 2 times 10 to the power of minus 6 coulomb, and then 1 over r minus a square. R is this distance of the point, that is 4.4, minus a square. A is half of this charge separation, because we are looking at the midpoint of the charge separation, that is 0.4 times 10 to the power of minus 3, and then we have to subtract the addition square. So that's going to be 1 over 4.4 plus 0.4 times 10 to the power of minus 3, and that's it. If you calculate this one, you should get 0.338, and that's in Newton, actually, yeah, Newton per coulomb, right? Okay, so this is our answer for the first one. Now let's look at the second one. Second question is asking 3 plus 3 microcoulomb point charges are at the 3 corners of a square of side 0.25 meter. The last corner is occupied by a negative 3 microcoulomb charge. Find the magnitude of the electric field at the corner of the square, and give the answer in Newton per coulomb. Now to find this one, let's draw the diagram of this one first. Okay, so this is a square right here, and each side is 0.5 meter, actually 0.25 meter. Each side is 0.25 meter, and then we have positive 3 microcoulomb, positive 3 microcoulomb, positive 3 microcoulomb, and one is negative 3 microcoulomb. Now let's name the charges. Let's say this is Q1, Q2. Let's name this one with different color, Q1, Q2, and let's say this Q3 and Q4. And we know that when we have a positive charge, the electric field goes away from it, and when we have negative charge, the electric field goes toward it. So from that information, we know that E4 is going to be in this direction, right? E4 is going to be in this direction. Also, E2 is going to go along this one, because that's a positive charge, so it goes away. And if you look at these charges, Q1 and Q3, both of them are positive. So Q1 goes in this direction, goes away from that one, so this is going to be Q1 in this direction, and Q3 is going to go opposite direction. And since actually I have to put electric field E1, E3, okay, E1 in this direction, E3 is going to be in the opposite direction. Now if I add E total, we are going to have, let's separate this part, E total, we are going to have E1 plus E2 plus E3 plus E4, and if you look at this carefully, we have E1 and E3 opposite direction but equal charge, right? Equal charge, opposite direction. It means it's going to cancel each other. So E3 and E1 is not going to come in this equation. E1 and E3 is going to cancel each other, right? So we are going to have E2 and E4. But if you look at this charge, both of them are 3 microcoulomb, but one is positive, one is negative. Since the magnitude is same, 3 microcoulomb, we can combine these two together and put 2 E2. Okay, I write E4 as E2, so we can write 2 E2. Now we can plug the equation of the electric field. That's going to be KQ over R square. And since they are asking for the midpoint, the magnitude of electric field at the center of the square, if this is the point, we know that each side is 0.25 meter. So if I use the Pythagorean theorem, I can find the diagonal of this square. That's going to give us R is equal to square root of 0.25 square plus 0.25 square. That's going to be the diagonal, but we want the midpoint only, right? Midpoint means half of this one. So R is going to be, if I say small r is the half of the point, half square root of 0.25 square plus 0.25 square, and that's going to give us a half of the point. And if you calculate this one, that's going to give you 0.177. Okay, now we can go ahead and plug it in this equation. Now let's do this part. We need some space, so let's grab this value and write this one right here, 0.177, and let's do the calculation right here. Okay, so here we are going to have ET is equal to 2 times K is 9 times 10 to the power of 9, and our charge is 3 microcoulomb, so 3 times 10 to the power of 6. I have to write it clearly. E total is equal to 2 times 9 times 10 to the power of 9 times 3 times 10 to the power of negative 6 over R square. We know the R is 0.177 square, and if you calculate this one, you should get 1,723,642.64, and this is in Newton per coulomb. And that's how we do this kind of problems. I hope this helps. Thanks for watching.